The MC move relative is a fundamental function block in motion control programming according to the PLCopen standard. Whether you are building a conveyor belt or a robotic arm, this is how you command an axis to move a specific distance from its current position. In this video we will break down exactly how this block works. I'm using CodeSys Soft Motion for this demonstration, but because we are using the PLCopen standard, everything you learn here applies directly to Siemens TIA Portal with technology objects, back of TwinCat, Schneider Electric, and many others. The logic is universal. I have already a virtual axis configured in the background. If you want to know how to set up the axis object from scratch in CodeSys and have detailed programming guides, theory background, examples and exercises, check out my full course on motion control in the link in the description. To use move relative, you need to create an instance of the function block and call it in your code, passing your axis interface in its axis variable. I am using FBD to visually show you all the inputs and outputs, but you can use any other IEC language like structured text or ladder diagram. I will show you simultaneously a trace of the axis position, velocity and acceleration, as well as a diagram showing the PLCopen state diagram. Remember, you can check the current PLCopen state using the MC read status function block. A critical rule for beginners: you must call this block in every PLC cycle, even when you are not moving. This is a rule for all PLCopen function blocks. They mostly work using rising trigger inputs, so even when the specific operation is not running, they are often handling background communication with the drive. Let's get through the function block parameters. As we've seen, the axis parameter must be configured to define which axis will be moved. Here in CodeSys, I'm passing the axis object defined in the soft motion axis pool. In other systems, you will pass different abstractions for the axis, like technology objects in Siemens or motion control axis in backoff. The distance parameter specifies how far the axis should move relative to its current position. This can be a positive or negative value, indicating the direction of movement. The velocity parameter defines the speed at which the drive will move. The acceleration and deceleration control how quickly the axis reaches its target velocity and how it slows down to a stop. The jerk controls the rate of change of acceleration. Adding jerk creates an S-curve profile, making the movement smoother and reducing mechanical stress. There is also buffer mode. This determines what happens if we trigger this block while another move is already active. The default is aborting, meaning this new command will immediately override anything else. The block is commanded through the execute boolean input. As many other MC function blocks, it will start the movement on a rising trigger on the execute parameter, meaning a transition from false to true. A move relative can be issued in one of these PLCopen states. The most common way is to start a movement from the standstill state, in which the axis is powered on and not doing any movement. To reach this state from the default disabled state, we need to use an MC power function block to enable the axis. Now, let's trigger a move. We will travel 100 units. Watch the trace on the right and the state the machine on the bottom. 3, 2, 1, execute. Immediately, the state machine transitions to discrete motion. On the trace, you can clearly see the three phases: the acceleration phase, the constant velocity phase, and the deceleration phase to a stop. Once the target is reached, the state returns to standstill. We can also see that when we raise the execute bit, the busy output will become true, and then, when the movement is complete, the done output will become true. Setting the execute input to false will reset all the boolean outputs. This is a common interface for many PLCopen function blocks. By triggering another rising trigger of the execute, by setting it to false and then to true, a new movement will start, that will reach now the 200 units position. Issuing another command, like an MC stop, while a move relative is running, will have it raise its command aborted output. We have covered the basics of discrete motion. You now understand how to parameterize the move, interpret the trace, and read the state machine. However, moving a single axis is just a start. If you want to learn more about motion control, check out my Motion Control with PLCopen course. Link is in the description below. Thanks for watching.